This is the fourth video of LeetCode randomization series. This time we want to support both the shuffle and reset of an array. There are a few given constraints. In the array, there are at most 50 elements, each of which is unique and its absolute value falls within 10 to the 6th. There will be at most 10 to the 4th calls to either the array shuffle or array reset. Remember that in the last video for LeetCode 382, I left a bonus question regarding how to random shuffle a streaming input. I'm going to cover the solution in this video. The solution is just a generalized version of Reservoir Sampling, which now holds all the elements at hand after random shuffling. Just a quick reminder of what we did last time. In the previous implementation, when the n-1 elements arrives, and there are a total of n elements, always roll a dice of values from 0 to n-1 inclusively. This index is 0 indexed, and we'll throw a value from 0 to index inclusively. Now this time, we are going to do random shuffling. We still need to go through each value in the value array. Even though this value is now an array, it will also work for a streaming input. In a streaming input, we'll always get the index and the incoming value. Now, instead of just getting the random integer from 0 to index and testing whether it's 0 or not, this time we actually want to assign it to JDX. Remember, it's still 0 and IDX inclusively. What we're going to do with this JDX is that's a target location for shuffling. So we'll do values index values JDX equals to values JDX and values index. You'll notice that the difference is that in the past, we only have one value on to hold. So if it's 0, we just swap with that value. But now we are swapping the values between IDX and JDX. And at the end, we'll just return this shuffled array. All right, now let's move on to the code implementation. Given that there's a requirement to reset the array from time to time, I would like to keep a copy of it. Original nums equals to nums. And I also want to have a current version of it so that I can manipulate on it. This will be self.nums equals to self.original nums.copy. You might be curious about the copy keyword. This keyword is actually critical here. If you don't have this keyword, you will be modifying the same array reference. Whatever you manipulate on nums will affect the original nums. So you will basically lose the copy you want to keep for reset. For the function reset, it's very straightforward. We'll do self.nums equals to self.original nums.copy, and then return self.nums. Lastly, for the shuffle function implementation, we like to iterate through the nums array. In enumerate self.nums, first we'll need to get the index JDX. JDX equals to random int 0 to dx. Remember that this index is 0 indexed, and the randint will take two values inclusively. So this is exactly the value we want to put in this function. Once we have JDX, we can start doing the shuffling. Self.nums IDX self.nums JDX equals to self.nums JDX and self.nums. In the end, we'll return self.nums as the result. And now let's test it if it works. Cool, now it passed the test case. Let's do summation. All right, you can see its result is at the median. It's around 50% of users. But yeah, that's the end of this video. And thank you for watching as usual.